Welcome students to the optional video, evaluating logs using the definition of logs. So you're talking about the definition of logs. The definition of logs just says log base a of x equals y can be rewritten using the circular motion. So that means that a to the y equals x. This is the definition. So if I'm rewriting this or evaluating this based off that, this says 3 to some power, which I'll just call these y. 3 to the y equals 9. So you ask yourself, well, 3 to what power gives me 9? So the answer to this is just 2. You don't necessarily need the y equals 2 because there wasn't originally a y. But when I have log base 3 of 9, what that is saying is 3 to some power gives me 9, which would be the second power. Evaluating again using that, this is 5 to the y equals 125. Well, 5 squared is 25. 5 cubed is 125. So the exponent here would be 3. 2 to the some power gives me 0.125. So I get 2 to the y equals 0.125. What might be helpful to think of this as is 2 to the y equals 0.125 as a fraction is 1/8. So I have 2 to the y is equal to 1/8. What's happening to this then, this exponent must be negative, which is what's creating a fraction. So I know my answer is negative. The negative for the exponent would make the 2 go into the denominator. So this is like 1/2 to the negative y equals 1/8. And you ask yourself, well, 2 to what power would give me 8? And that would be to the third power. There we go, third power. So the negative third. The negative is what's creating, again, the fraction. The 2 cubed gives me 8. Using that same idea, I get 10 to the y equals 0.0001. That's the same as 10 to the y equals 1 over 10,000. So the fact that this created a fraction means my answer is negative. 10 squared would be 100. 10 cubed would be 1,000. 10 to the fourth would be 10,000. So this is the negative fourth since it made it in the denominator. So that's just evaluating using the definition of logs. Now, what we're going to do is solve each equation for x using the properties of logs. And some of this is sort of the same, but we're going to treat it a little bit differently. So what I want to do is use the properties. Now, I'm not going to use the circular motion. I know the answer is 2. 3 to some power gives me 9. But I want to show it in a different way. Using the properties, I could rewrite this as log base 3 of 3 squared equals x. So I rewrote 9 as 3 squared. One of our properties of logs is if you take the log of an exponential function with the same base, it simply cancels. And this 2 is just the final answer. So 2 equals x. In this case, you have that same thing, log base 5 of 5 to the fourth. So the logarithm and the exponential cancel, and I'm left with just this 4 equals x. That 4 no longer is an exponent because I've just done the inverse of an exponential. Log base 2 of x equals log base 2 of 12. If I have the same base in a logarithm and the two things are set equal, then the arguments are equal. X equals 12. And last, again, log base 3 of 3 to the x. If I have a logarithm and an exponential that have the same base, those cancel, and I'm left with x equals 18. And then looking at the graphing. So the graphing is really where it's going to be a bit tougher, or arguably a lot tougher. Find the domain, vertical asymptote, and x-intercept, and sketch a graph of each function. So for 1, We're going to start off with the fact that we need 3 points, 1 over a negative 1, 1, 0, and a 1. Remember, those are basic points. So the first thing that I do when I look at these problems is I list these 3 points. Here, a is 3. So I'm going to have 1 over 3, negative 1, 1, 0, and 3, 1. And I list them like that with room to work downward because we will do something to these going downward. Then I look at what changes have occurred. So I have this plus 5. This plus 5 is a vertical shift because it's outside of those parentheses. So it's going up 5. But we want to take this a step further. If I'm talking about going up 5 units, what I'm talking about is changing the y values. So what I do is I go to these coordinates and I take the y values and I add 5 to them. This gives me 1/3, 4, 1, 5, and 3, 6. So now if I'm going to part of this sketch, I'm just going to draw all my sketches in right away. As always. Ooh, that one did not come out right. So now that I have those drawn, if I'm looking at this, I have 1/3, 4. So 1/3 is right here, 4. 1, 5, and 3, 6. You can notice here my vertical asymptote is still going to be this x equals 0. Because if I have a vertical asymptote of x equals 0, that is not going to change with a vertical shift. A vertical shift isn't going to change that asymptote. So my asymptote here, x equals 0, I can't cross over that. So my function will come down from here and go up through these points, even though it missed that one. We could just, throw it on there. There we go, I didn't miss it. See, ha 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 ha. Continues on in both directions. Now, the other thing that this is being asked for is the x-intercept. And I want to wait to come back to this, so I'm just going to box it off, because this first example is actually the toughest example of finding an x-intercept, and we'll talk about why. Domain also, is this can only exist in the positives, so x is positive. All right, looking at this next one, then we'll go back and do that x-intercept. Looking at this next one, and I'm going to do it slightly different. What I notice here is that this -3 means I'm going to the right 3 units. So what that means about my vertical asymptote, I just took x equals 0 and shifted it to the right 3 units. So now, oh wow, I missed that entirely. Now my vertical asymptote will be x equals 3. My domain, it's usually x must be positive to the right of the asymptote. No reflecting has happened, I've just shifted that over, so now it's x must be greater than 3. For my points then, what I do sometimes with my points, and it sort of varies on whether or not I'm going to do coordinates, or otherwise I do a table. The table is helpful, it's just a different way of organizing. So our coordinates go 1 over a is 2 here. So 1 over 2, negative 1, 1, 0, and a, which is 2, 1. I leave room to the left and to the right of this, so that if I need to change x values, I can change them to the left, change y values to the right. So the only change I have happening here is I'm going to the right 3. That means what I'm doing to my x values, and only to my x values, is adding 3. If I add 3 to 1/2, I get 3.5. It's totally fine if you leave that as a decimal. 3 to 1 would be 4, and 3 to 2 would be 5. So now I'm not plotting these x values. Those were the basic x values, but I shifted them. So this will become 3.5, negative 1, 4 comma 0, and 5 comma 1. Draw my logarithmic function going through. The other question that's asked is for the x-intercept, but this table already has the x-intercept, 4, 0. And that's what mainly happens, but does not happen for this question. If we looked at those coordinates, it didn't have an x-intercept because none of the y's were 0. So that's why we're going to come back to it and talk about it last. All right, doing this next one. Again, I'm going to do this one as a table because I think it's helpful for this one. So 2 changes here. 1, this is to the left 3, which is a change in my x values. This is a reflection, and it's over the x-axis, or it's changing my y values. So a couple things I'll answer first. Domain. I flipped over the y-axis. I'm sorry. I flipped over the x-axis. I'm changing my y values. So all I'm doing is taking things that were up here, putting them down here. That's not changing my domain. I'm going to the left 3, though. So I have x equals -3 as my vertical asymptote. All I'm doing to this function is flipping it up this way. So that doesn't change my domain. It still has to be greater than -3. You can always answer this question last, after you've sort of seen the graph. Talking about my coordinates then. I have 1 over a here's 5. So 1/5, comma -1, 1, 0, and 5, 1. 2 things are happening. I am changing my x's by going to the left 3. So I'm going to subtract 3 from my x's. 1/5 minus 3 is -2 and 4/5. You know, cool with the mixed number here. If you want to put a decimal, if you want to put a fraction, what's going to be important is just that you have that right location. 1 minus 3 is -2. 5 minus 3 is +2. What's also happening in this problem is I'm changing my y values by changing the sign. So looking at my y's now, all I'm doing is multiplying them by -1. I'm switching the signs. So it becomes 1, 0, -1. So now looking at this table, these were the basic x values, the basic y values. I'm plotting the new x and y values. So -2 and 4/5, comma 1, -2, 0, and 2, -1. You can see here my logarithmic function goes like this. It's been flipped over from the original one because of that negative, and it's been shifted to the left 3 units. The x-intercept happens in this table, -2, comma 0. All right, moving along. Log base 10 of -x. This -x, I'm changing the x values by reflecting over y. So, I'll just start with the coordinates first. And I'm going to do them as coordinates in this case since there's just one change. I have 1/10 -1, 1, 0, and 10, 1. And all I'm doing to this is changing the x values. So I'm changing x by multiplying by -1. -1/10, -1, -1, 0, -10, 1. If I go and plot them, -1/10, -1, right about here, -1, 0, and -10, comma 1. You can see here I have my logarithmic function. And looking at this graphically, now you can sort of see, oh, my asymptote is x equals 0. my domain, because of this change in x, it's now x is less than that asymptote, 0. And my x-intercept is already found in the table. All right, so then going back here, we had an x-intercept that was not in our table. Now this only happens when I have a vertical shift, and what you'll learn is with logarithms, if you see a vertical shift, that makes it just, a little bit tougher. What you need to be thinking about is, right here is my x-intercept. I don't know what that is. But what I do know is that happened, or that came from what was originally 5 units down here. And then it got picked up 5 units by this plus 5. So what I can do in that case is take the base, 3, and say the 3, originally this would just be 3 to the 0 power, right? Yeah, 3 to the 0 power. Yeah, and then 0. But what I've done is shifted this up 5. So you need to be thinking backwards, like what was this when I went down 5 units? So this becomes 3 to the negative 5, comma 0. Because I just had said, okay, I need to sort of work backwards. It was originally 3 to the 0 power. This is the same thing as 1. And I'm moving back down. So 3 to the negative 5th. 3 to the negative 5th is going to give me, 3 squared is 9. Times 3 again is 27. Times 3 is 81. Times 3 is 243. So this is 1 over 243, comma 0. So this would be our x-intercept. And again, what you want to be thinking about, and there's sort of some other sort of weird cases, but you want to be thinking about taking to the base to the opposite of the vertical shift. Now that is not a science, because there will be cases where that does not work. But what you can always do is just look at your graph. So if I did 3 to the negative 5th, doing the opposite of the vertical shift, I get 1 over 243, and that looks about right. What happens with some people is they'll accidentally do 3 to the 5th power, and that's 243. Well, 243, that's way over here. My computer screen doesn't go far enough. So you should be able to just look at your graph and be like, yeah, I don't think it's 243 comma 0 because I can see it's really close to 0. What happens for other people is they get something like negative 1 over 243 because of that negative. It sort of throws them off. So then you're like, oh, okay, yeah, it's really close to 0, but it would be on the other side of this asymptote. So in the case of these vertical shifts, I really recommend, do all of the other work first, just like I did. I graphed this whole function totally ignoring x-intercept. Then go back and try and get that x-intercept. And when you get a final answer, just think does it even make sense for my graph? And if you're confident with your graphing abilities, which could be or should be, then you should know whether or not your answer even makes sense. All right, yeah, so graphing, that's going to be the toughest thing. All that other stuff, just make sure that you understand what a logarithm is and the way that it can really be written in exponential notation. That's going to be a huge key thing of understanding logarithms. Get started on some of that bookwork, bring some questions if you have them.